the Chapter 6 review. Mr. Godfrey should have handed out the notes. Make sure that you're ready to go, and we're going to get started right away. My goal here is to simplify the radical expression. The way that I do that is by factoring. I want to take this radicand, and I want to factor it in to as much as I can. Remember, the radicand is the thing inside the square root. So 12 times 10 is 120, so I'm going to factor it out that way. Now I have 3y's, and I have 6r's. I don't have to write all these out every time, but it's going to help for the first one just to visualize what's happening. Now, I already want to take out as many groups as I can, and the way that you tell how many are in a group are based on the index of this radical. And since it wasn't written there, we assume it's a square root or a second root. That means the index is 2. That means I'm looking for groups of 2 things at a time to take out. I see I have a group of 2y's, so y will go to the outside, and you can see that I have 3 groups of 2r's. 1, 2, 3. So I take out 3r's, or r to the third power. I continue to factor 12 times 10 into 6 times 2 and 2 times 5. And don't forget the r cubed y on the outside. Now looking for another group. I can take a group of 2's out there. So that goes on the outside. So I have 2 r to the third power y, and what's left inside of the radical? A 6 and a 5, that makes 30. That would be my answer. A similar situation happens when the index is different than 2 and the index is 3. I will do the same exact method, except now I want to factor in and I want groups of 3 at a time. So 54, you should know that that is 27 times 2, or if you don't know that, you could guess another number that goes in there, 6 times 9. We can do 6 times 9, that's fine. Now I'm not going to write out all the w's and all the y's because that would take way too long. Instead, I'm going to think to myself, how many groups of 3 can go into 6? Again, how many groups of 3 can go into 6? 2 groups, so it'd be w squared. How many groups of 3 can go into 4? 1 group with 1 left over. So I have a y on the outside, and 3 of the y's went away, but 1 is still left. I can't factor in the numbers yet because I don't have any perfect squares underneath. So I have y times w squared times third root of 3 times 2, that's 6. And then 9 is 3 times 3. How many do I need to get out of this radical? 3 of them. I have them here. It's going to go to the outside, a 3 on the outside. So 3y w squared times the third root of 2. That would be my answer. A lot of you made mistakes on this problem on the quiz, and you mistakenly wrote 7 times the square root of 40. You simplified that into 4 times 10. But that's wrong. I cannot add these together because they are not like terms. So the first thing I must do is try to see if I could simplify the radicals. If I could simplify the radicals, then I might be able to add these together eventually when they have the same radicand. 8 is 4 times 2. 32 is 8 times 4. I'll keep factoring. 2 times 4 is 8 times another 4 plus square root of 2 times 2 times 2. You can see now that I could take out groups. The group of 4's here I could take out to the front. What am I going to do with this 4 and the 7? You should know this time I'm going to multiply. 4 times 7 is 28. Square roots of 2. Take out a group of 2's from this radical. 2 square roots of 2. Now you can see clearly that I have the same index and the same radicand. The square root of 2 here is the same as the square root of 2 over there. So these are actually like terms. So when I add them together, how many square roots of 2 do I have? 30. My answer would be 30 times the square root of 2. Same situation here. I just have 3 radical expressions or radical terms here, so I want to see if I can simplify. Well, 3 times 5, that's not going to help us. There's no perfect squares, so 3 times the square root of 15 is going to be the same. How about 35? 135. Well, if it ends in a 5, 5 probably goes in there, but you might not know how many times. And since you don't have a calculator, you have to figure it out by hand. This is going to be a pretty easy division, though. Goes in there twice. It's 10. 3 left over. Another 5. 7. 5 times 27. 3 square roots of 15 is going to stay the same because, like I said earlier, you can't simplify the square root of 15. Okay, square root of 60. 60 factors into 10 times 6, or you could think to yourself 4 times 15. Either one. I'll do 10 times 6. It's more familiar. It's probably more likely what you would have guessed. 3 square roots of 15 isn't going to change. 27 is 9 times 3. Minus, and then 10 is 2 times 5. 6 is 3 times 2. All I'm doing right now is just factoring out my radicands as best as I can. So I'm looking for groups. Groups of 2, since they're square roots. 5 times 3 times 3 times 3. Okay. Minus. This one's completely factored. I can take some things out right away out of that one now. Let's do that first. Take a 2 out. So 2, and then it should be 5 times 3 left in there, square roots of 15. What can I pull out of this one now? A 3. So I have 3 square roots of 5 times 3, which is 15, minus 2 square roots of 15. And then I still have the 3 square roots of 15 from the front. And notice how I had to pay attention. I brought everything down so I didn't lose anything. Now I have 3 square roots of 15 plus another 3 square roots of 15 minus 2, and these are all like terms. They're like terms because they have the same radicand. They have the same thing in the same radical, same index. These are all like terms. 3 plus 3 minus 2 is going to be 4. My answer will be 4 times the square root of 15. This is one that people still struggle with mightily. Everybody has troubles with this. When you have the square root of a fraction, your first step is to see if I can reduce the fraction. Can I reduce that fraction? No, I cannot. If I cannot reduce the fraction, split it into its own radicals, in the numerator and the denominator, and then try to simplify. Well, the square root of 16 you should know by now is 4. I'm not going to even show the breaking up for that one. Now I have 4 over the square root of 7. This is a problem for you. You do not want to have a square root in the numerator or the denominator. Sorry about that. Let me get rid of my email here. Do not want to have the square root in the denominator. So I have to multiply by the square root of 7. And the reason I'm multiplying by the square root of 7 is I want to have 2 7s in that radical to get rid of it. So now I have square root of 7 times the square root of 7. In the numerator, I have 4 times the square root of 7. A lot of people made a mistake on the quiz and they had the square root of 28. You do not multiply the 4 and the 7 because the 4 doesn't have a radical and the 7 does. Now you should know that I could pull these 7s out and the radical goes away. I have 4 times the square root of 7 over 7, and that would be my final answer right here. When I have a product involving a sum with a number and a number with a radical, I must distribute this to both items. So I'm actually going to distribute that to both terms. So it's going to be 6 times, 6 was already in there, 6 times 2 square roots of 2 plus 3 times the square root of 6 times 2 square roots of 2. So notice that I actually distributed that to both terms here. That whole thing, 2 square roots of 2 came here with the 6. 2 square roots of 2 is here with the 3 square roots of 6. Now how I handle this once I try to distribute is I multiply the numbers on the outside times each other and the numbers on the inside times each other. And so notice on the first term, right here. And when I say that, the first distribution of 2 square root of 2 times 6, there was no radical there. So I'm just going to multiply the 6 and the 2, and I get 12 square roots of 2 plus 3 times 2 is 6. I have the square root of 6 times 2. Okay. I'll try to factor out, actually I can. So 3 times 2 times 2. So that's all still into the radical. Now notice the square root of 2 is done. I can't do anything else there. Alright, I'm going to move down a little bit. 12 square roots of 2. What can I pull out of the other one? You shall be saying a 2 at this point. So 2 times 6 is 12 on the outside, square roots of 3. And that's it. I cannot combine these two. Why not? Square root of 2, square root of 3. Not like terms. Oops. I think I went too far there. Nope. Sorry about that. Okay, last thing, solve equations for x. Use inverse operations to try to get the x squared by itself. Subtract 21 from both sides. 3x squared equals 4. Divide both sides by 3. X squared equals 4 over 3. To solve for a exponent, to get rid of that exponent, I need to take the square root of both sides. And when I do that, you should know that I get two answers, unless I have 0 on one side. I'm going to have x equals the positive square root of 4 over 3, or x equals the negative square root of 4 over 3. And just like I did before, I have to separate these fractions out. If I can't simplify the fractions themselves, take the radical of the top over the radical of the bottom. What's going to happen there is I get the square root of 4 is 2 over the square root of 3. That's a problem. Why is that a problem? I can't have what in the denominator? Square root of 3. So I'm going to multiply by the square root of 3. This is called rationalizing the denominator. X equals 2 times the square root of 3. Notice that the 2 and the 3 do not multiply, because they do not have the same index. This is not a square root, this one is. And finally, I have my answer. Don't forget to have both answers in there. Alright, one last one. Subtract 7 from both sides. 5x squared equals negative 5. I divide by the 5. X squared equals negative 1. I try to take the square root, but as soon as I try to take the square root, you should notice something. There's a negative number underneath the radical. That's a problem. There should be no real solution when you have the square root of a negative number. Now be careful. That's only when the negative's inside. I could have the negative square root of 2. That's okay. But I cannot have the square root of negative 2. At least not in Algebra 1. Make sure that you study hard. Make sure that you work on your worksheet today. If you need to rewind and watch any of this again, you can. I will be putting it on Schoology. Remember, you have a test tomorrow. Message me if you have questions. Go ahead and make sure you watch all the videos for this unit as well.